Hello and welcome. I am Dr. Anil Joshi. Welcomes you to my series Learn Radiology with Dr. Anil Joshi. Today's topic is based on the physics, that is also CT physics, and that particularly on CT tubes. CT physics is extensively large topic and is covered in multiple portions. Now this time it is CT tube. To start with are the disclaimers. Most of the material we are used in these illustrations is from our departmental, used for the teaching purposes from many years. However, some of it is downloaded from the net, which we are confirmed is royalty free. With this brief acknowledgement and disclosures, let's get going to the topic about the physics, CT tubes, and how they are constituted. Now it's all about CT tubes today. Actually, CT tubes and X-ray tubes, there is not much difference as far as a basic principle of concern. Both converts electricity into the X-ray energies. However, the problem is CT tubes needs larger capacity of heat dissipation and production of X-rays, while X-ray tubes for radiological purposes don't need that much. Now, in this we are going to see a combination of CT tube and detector, which is in conventional radiography as a X-ray tube and a cassette. Now here X-ray tube is of lower capacity. Cassettes are usually either digital or it can be a direct radiography. But in CT, it is the CT tube which emits the X-rays, then there are filters, collimators, then array of detectors. Now as far as detectors are concerned, extensively it is covered in other lectures. Do visit our website, do see our list of lectures, and you will find there is a different lecture for CT detectors. In this lecture we are going to see only CT tubes. Now, dramatic increase in performance of conventional CT scanner over last 20 years has required a sufficient improvement in the technology of X-ray tube used for CT scan. That is mainly because we are going for rapid sequences. CT scans, we are going for fraction of seconds, and for that we need a higher capacity, which we are going to see in this lecture how it is achieved. Today, a metal, that is a tungsten, then rhodium and molybdenum are used. The target is branched to a thick graphite block for improved heat dissipation. So here the main principle is a good heat dissipation. A target diameter up to 20 centimeter are used with rotational speed up to 10,000 rpm per minute. Now both are very high as compared to the X-ray tubes. Now the target is operated at a temperature of 1200 degrees centigrade and the area around the focal spot reaches over 2500 degrees centigrade. So this high heat need to be dissipated, tolerated, and more fast we achieve this, we can go for a faster scanners. We can go for a better capacity tubes. Now the maximum heat dissipation of this tube can be reached up to 10 kW. That is a dissipation. Please note, dissipation is up to 10 kW. Still, the major limitation in the use of CT scanner imposed by the CT tube is the maximum permissible sustained X-ray power, which we are supplied by the government. So that power has got limitation. In that we have to work, and in that whatever we can achieve best results, that we have to go for. A further increase will require major development in target cooling. We have seen just now it is 2500 degrees centigrade. For example, a liquid cooled rotating targets are preferred, then bearing system which can tolerate high RPM, and generation of the electronic beam which can be faster. X-ray has to be faster, detector has to be faster, computer has to be faster. So it is not the X-ray tube alone, but it is combination of multiple things which are required for these operations. Now, like those used in angiography, tungsten, which has an atomic number of 74, is usually used for the anode target material. Is same. This produces a high intensity X-ray beam, since the intensity of X-ray production is proportional to the atomic number of the target material. That's why the tungsten is preferred. The multiple small focus spots are there in CT tube, usually of around 0.5 to 1 mm size. Then computed tomography tube produces a sharper image because of the reduced penumbra, everything we have seen in the X-ray topics when we have covered how an image is produced, how these things occurs, and this penumbra, if you want to remove, what we are supposed to do, that we have seen all in a X-ray lecture, physics lecture. That is same principle applies here. Now heat concentrated into smaller areas of the anode, which dissipates at multiple places. In conventional, it is only oil, versus here there are a lot of additional things which you are going to see subsequently. Now scanning protocol often require multiple long exposures and rapid exposure. The total number of patients are also numerous. They are increasing day by day. The scanning time is increasing because we want good resolution. Now we want to have rapid scanning, and all this is attributing load to the tube. Now these create a lot of stress on the tube. The details of the generator and tube cooling capacities are different in different machines, and with that they give you something like tube calibration, where we can do rapid sequence X-rays, rapid sequence CTs, or we can have a higher longer time CTs. Now generators maximum power is usually limited to kW, while the anode heat capacity is listed in billion heat units, that is MHU. These specifications can help to differentiate various CT scanner, and you can buy the scanner of your specification and your requirements. These values represent the highest limit of the tube performance. Now filtration, in order to shape the X-ray beam, compensating filters are used. These reduces the radiation dose to the patient and minimize the image artifacts. Radiation emitted by a CT X-ray tube is polychromatic. By filtering the X-ray beam, the range of the X-ray energies reaching the patients are also reduced. These filters remove X-rays of long wavelength or the soft X-rays because they don't contribute to image formation. If they are there, they just produce a scatter or they become a noise. So we do not want these X-rays of low penetration or low energy levels to form the images, because we want a sharp image free of artifacts. Now CT images are improved by creating a uniform beam intensity by filters reducing artifact resulting from beam hardening. Now different filters are used when scanning the different body portions. The body scanning filters are used to reduce the beam intensity at the periphery of the beam corresponding to the thinner areas of patient anatomy. These are referred to as a bow tie areas because of their shape. Now as I told you, the X-rays which are going to form an image are only useful those who are going to just with low energy create fog or artifacts and haziness. We do not want it. Now collimation restricts X-ray beam to a specific area, which helps to reduce scattered radiation. It controls the slice thickness by narrowing the widening the X-ray beam. It is located adjacent to the tube. Now its role is also to produce a streamline or a required thickness beam. Now scattered radiation reduces image quality and therefore increase the patient's radiation dose. Unnecessary patient is receiving more radiation, and the radiation which patient is receiving is not contributing to image. So what's the use of it? So better to cut it off. Now reduction in scattered radiation improves contrast resolution, decrease patient dose by decreasing amount of X-ray beam before it passes through the patient. Now comparison of X-ray and CT scan tube. I think it's not really a good thing to compare these two. Both are at two ends. However, basically or by principle, they do same thing, convert electric energy into the X-ray energies. There are no differences in basic design of the X-ray tube used to conversion of the used for conventional radiographs and CT scan. However, it does not mean that they are same. An X-ray tube is basically a diode, that is, electrons are emitted from a cathode, and because of the high voltage between the cathode and the anode, they slam into the anode with a lot of energy. Conversion of electric energy to X-ray energy is not 100%. Therefore, residual energy is converted into heat. Almost 99% of the heat is produced, and hardly there is 1% which is used for a good X-rays. Modern X-ray tubes use rotating anode which distributes the electron over a larger surface so that heat is not concentrated in one spot. It is made up of tungsten having a high melting point. Now, X-ray tube in CT machines are exposed for a longer time. That is, the exposures are long, they are more with MA, they are more with MAS because the exposures are long, and therefore they are more than that of the conventional. The anode has to dissipate this large amount of heat that is generated. Therefore, anode is designed to have a longer diameter to speed up heat dissipation. Now, CT tube housing also have liquid for cooling. Tubes for conventional radiographs have oil surrounding the tube inside the housing for absorption of the heat. Now, these are the differences in between these two. Now, modern CT scanner tubes. The tubes of modern CT scanners usually have a metal instead of glass envelope and a much larger anode, about double the diameter of the conventional X-ray. The anode is rotating by an external set of coils that gives them more RPM than that of the routine X-ray tube. The motor is outside the tube and it is of more higher capacity. Then efficiency of X-ray tube detectors and glass becomes brown in color due to long exposure. So this factor has to be taken into consideration when calibration. Additionally, it gets darkened due to high energy of the electron hitting it, resulting into high temperature. Now, this reduces the capacity of the tube. This reduces the resolution, and therefore regular calibration is required. Some of the metals of the anode may be vaporized and get deposited over inner surface of the glass. These problems are more with a CT tube as compared to that of the X-ray tube. Now, these are the designs. You can see routine X-ray tube. Here idea is to get the designing basic, that is, the voltage is applied, it is applied to a cathode, cathode produces thermionic emission, electrons are produced with a focusing cup, they are bombarded towards rotating anode, then they are accelerated to gain the energy, and here it is converted into the photons, that is X-ray energy. And this is the CT tube. What is the take-home message? It is important to understand tube design and requirement of the application. What application, how much heat dissipation you want, that determines your tube design. Design of anode, cathode, protection of X-ray, production of X-rays are extensively covered in many lectures. Do visit our website and get advantage of it. Due to high heat production, suitable designing is made to dissipate the heat, as we have seen in lecture till now. Now, role of filter, collimator is also important for improving image quality. Not only by putting a high capacity tube you can achieve the results, but you will have to have proper filters, collimators, etc., so that you can get good image. With that, we are coming to end of lecture. I thank you for your kind attention. In case you need more details, do visit our website. There are a lot of lectures on a lot of different topics and in different ways. There is academics on the YouTube channel as well as our website. Thank you, goodbye, and good luck. Take care.